Hi there, namaste. Hope you're doing fine. My name is Ajay Patha, and firstly, let me give you a high-level overview. The front end is developed using HTMX, and in the backend we have FastAPI with Python, and here we are using prompts which will be converted to PostgreSQL query, and we run the query on our database to generate the result from our database. We have three tables that are like flight, airline, and airport. Let us quickly check the basic prompt, like list all flights departing from JFK airport in 2015. The results have been generated. Since the table contains more than 5 million data, there is a probability that user prompt might generate a query that returns a huge number of rows. So I have allowed for the pagination. Let's try another one from the airline table. So all the airline data. So here we have the airline data. Now let's try the one which tries to modify our database. Say like delete all rows from the flights where the airport is JFK. We get this error stating that we don't intend to run queries that modify the database. Now say select queries are only allowed. For the backend, we have two endpoints. The first one generates the SQL query from the prompt. Like let's say, try again, list all the flights that are from JFK airport. This returns us query ID and the query. Let me copy this. The second one takes in the query ID, and here we can add the limit for the pagination, limit and offset. And then what it does is like takes in the query from this and adds the limit and offset if not already provided by the LLM. And then we can use these for the pagination. This is all for the high-level overview about the implementation process. Firstly, I downloaded the Kaggle datashet, then did a quick data exploration for the given datashet. It seems that it consists of 3 CSVs, so I need to make 3 tables. We could integrate it into one, but sometimes we won't have that freedom, so I'll be using 3 tables, that is airlines, flights, and airports. After a quick review, I assume that the IATA code from airlines and airline from the flight have a foreign key relation. Similarly, IATA code from the airport and origin airport and destination airport from the flights have the same relation. Also, I noticed that the flights thereof is pretty huge. That is about 5.8 million. So I need to be considerate about this while populating the database. Then I started building the table using SQL model. SQL model combines the best of SQL Alchemy and Pydantic, making it easy to define models while keeping migration smooth with Alembic. So I have defined the class for the tables. After this, I populated the data using the script, where I'll be populating the data using bulk insert. Here, like as I've told you before, file system df is pretty huge, so I'll be chunking. I'll be using bulk insert by chunking, so that we won't run out of memory. Also, I have written few lines of code so that we can validate the foreign key relation. With the database ready and populated, now I needed to choose the LLM. Firstly, I was trying to DeepSeek retrieve with Hugging Face half. In France, it was giving pretty good result, but I quickly ran out of credits, so I'll be using Gemini 2.0 Flash. Here I have kept the temperature at 0.2 pretty low, because we don't want any creativity during the PostgreSQL query generation. Also, I have kept the top p value to 0.9 pretty high, because like we want the probability of tokens to be fallen within the cumulative probability. Also, for the response schema, I have defined a JSON class from using the Pydantic model, so that we'll get the valid JSON response. For the prompt, I have initialized it with the actor, like SQL Assistant specializing in Postgres. Then I have given a context about our database, and I have added some text to make sure that the response is valid. And also for the output format, I have provided the JSON format so that it will be easier to integrate later on. And from here, I'll be outputting the SQL query from the LLM. About the API, we have two API, generate query and execute query. This generate query endpoint will firstly take in the text, and then calls the LLM so that we get the PostgreSQL query. Once we get the query, then we sanitize the query. So by sanitizing, I mean like we only want the query with select. Anything that modifies our database should not be valid. So I have added some case checks, and also I have removed the limit, because we want to use our own limit for pagination. After that, like we cast the query in a unique key using UID. Generally, we would be using Redis for caching purposes like this, but this is just a demo, so I'll be using dictionary. In the production, it will generally be Redis, and we'll be outputting like query ID and the sanitized query. The execute query endpoint will take in the query ID and limit and offset from the front end. For the query ID, for the query ID, we'll be just checking like if the query ID is already contained in query cache, and we'll be using that ID to get the sanitize query, and we'll be adding our limits and offsets for pagination and execute the query against our database from where we will get the result. For the easier deployment and like scalability, I have used the Docker Compose. I have instantiated the DB and API container API Docker containers. For running the project, I have provided all the details in the README. Firstly, we just do the git clone, then copy the environment, make sure to put in your own Gemini API key, then do the Docker Compose build, and after that, like you can use this command to populate the database. The front end is pretty basic. The front end is using HTMX, and we are just using simple styling and all other things with a basic pagination control and all. Thank you for bearing me with this. Please let me know about any feedbacks or comments. Thank you.